from measuring instruments, we will see kWh meter, or that is called as energy meter. What we will see? It is energy meter. So what is basically energy meter? So the meter that calculates the electricity bill in our home or in domestic or industrial purposes, it is called as energy meter. Or in exams they ask you write a short note on energy meter or draw a diagram of kWh meter. That also means energy meter only. That is kilowatt hour. Okay, so energy meter records the energy in kilowatt hour consumed during the whatever we consume, whatever the load. So whatever the load in our home is there, so who calculates the energy electricity bill? Energy meter. It calculates the how many units we have consumed. So we will see what is the construction and working of this kWh meter. In exam they ask you to draw the diagram of kWh meter, or they will simply ask short note on energy meter. So you have to draw the diagram and give the explanation how it works and what is the construction. So now starting with the construction, we are dealing with energy meter. It is used in our home in domestic purposes or industrial purposes. So in India, the supply we get is single phase AC supply. So I will draw here single phase AC supply. So I'll draw here the ICDP switch, that is ICDP switch over here. Now in this construction, for drawing the diagram, it is very easy. Just remember, it has three magnets. First one is shunt magnet, second one is series magnet, and third one is braking magnet. Okay, now just remember these three magnets. In kWh meter, it has a shunt magnet, series, and braking magnet. In shunt, what does it mean by shunt? Shunt means parallel. Okay, shunt means parallel, and series, that means in series with the whatever we are going to connect. So it is in series. This is shunt and braking magnet. So first I'll draw the shunt magnet. So it is basically in E shaped. So I will draw here. So as it is saying, it is shunt, that means series. So we are going to connect. So this must get phase and neutral, right? So this is coil, and now from here it will go to, this is our neutral, it will go to neutral. Okay, clear with this shunt magnet? What I have did here, this is our coil that is wound on this. This is our shunt magnet. I have wound the coil and given here. Now second magnet, it is series magnet. So this is E shaped, this is C shaped. Okay, now this is our series magnet. Now here to this magnet, I'll take this and wound here, and from here I'll give it here. Now it should get neutral, but here we are going to give it first to the load. Okay, load, and then to the neutral. Can I give it here directly? Because this is going to neutral. I can connect it here, or else I can give it here also. So I have connected it here. So this is the shunt magnet, this is our series magnet. We have given here load with series with this series magnet. Okay, now here the shunt magnet connected across the supply. Shunt magnet, it is connected across the supply, which carries the current proportional to the voltage. Now this magnet, it is connected across the supply and it carries the current which is proportional to the voltage. Now this is the series magnet. So series magnet is connected in series with the supply and carries the load current. You can see the load is connected to this series magnet. Okay, it carries the load current. Now this shunt magnet is made of highly inductive. Okay, it is It is highly inductive for the current lags voltage by 90 degree. What happens here? Current lags by 90 degree. Current lags voltage by 90 degree. Now, so this is the basic construction. Now moving further, here what I'll do, I'll place here aluminium disc. Okay, this is my aluminium disc. Now this is my spindle, and here I have this gear mechanism, or here you can say the number, whatever, 1, 0, 1, whatever the number it may be. Now this, what will happen? This is our aluminium disc. Now what is happening here? Current is flowing, right, through this magnet also. Current is flowing through this magnet also. This is the coil, right? This is the coil. This is the coil. Now what will happen? Here is one magnet, here is one magnet. Now what will happen now here? The flux will get generated, right? This flux will get generated and they will cut this disc. Now the current is flowing through this. Current is flowing through this, a load current is flowing through this magnet also. Whenever the load is in our circuit, whenever there is load, this will be in existence. Just remember the relation between this. Whenever it is here, load is there, this will be present. Okay, now both are the magnets, flux will be created. What will happen? This aluminium disc will cut this flux, EMF will be induced, and this disc will start rotating. Okay, this disc will start rotating. Are you getting the point? Whenever our load is on, our disc will start rotating. Here, why? Take the example of auto rickshaw. What happens? There is meter. When we sit in the auto rickshaw, when the rickshaw starts, then meter will start, right? Same here, the principle is there. When load is there, when load is on, then this disc will rotate, right? So in rickshaw, whatever the distance we have traveled, it calculates, and that is our bill. So here, whatever the load, whatever the appliances are on, depending on that, this disc will rotate. Okay, now what is happening here? Flux are created, the EMF will be induced, this will rotate, this disc will rotate. This disc will rotate, this is our spindle, this also will rotate, and due to that, this will also rotate, right? Now, this rotation we have to control, right? This will not already turn, or it will not rotate every time, right? We have to control this. So here the third magnet, that is what? Braking magnet is used. Okay, now here braking magnet is used. So how it works? Now this magnet will also have north pole, south pole, it will have poles, right? Here the magnet is there, our disc is rotating. What will happen? EMF will induced here. This, that means the current, AD current will get induced in this disc. This AD current will oppose the rotation. Okay, this AD current, now this disc is rotating, it is placed in the magnet. What will happen? AD current will get induced, and this AD current will oppose the rotation. It will not stop, it will just slow down the rotation. Okay, it will not completely oppose, it will not completely stop, but it will slow down the rotation. The disc will not rotate, just continue on rotating. It will rotate, but in slowly. Okay, now what is happening here? Our disc is rotating due to this mechanism, this spindle. Here, whatever, it will count 1, 2, 3, whatever. Now in some meters there are some constants. Now here, if our disc rotates 10 times, then here unit will be 1 unit. Just consider, if our disc rotates 10 times, then our unit consumed is 1 unit. So our meter will show 1 unit. If our disc rotates 20 times, then unit showed here will be 2 units, right? It is in proportion. If disc our rotates 200 times, then 20 units will be consumed. It will be showed here. Now 1 unit cost us 3 rupees or 4 rupees, whatever it is. Just consider 4 rupees, okay? So 1 unit cost us 4 rupees. So 20 units, we have consumed here 20 units. So what it will cost? 20 into 4. So this is how our electricity bill comes. So this is the construction and working of kWh meter. So it is very easy. In this energy meter, there are some drawbacks, or you can say errors. So what is the basic error? Whenever the load is off, right? Whenever the load is off, in you can say in many cases what happens, in our home all there is complete shutdown, or we have not turned on the lights, our home is closed, but still we get some bill. Why? Because there are some errors in this energy meter. What happens, this disc rotates, means it rotates slowly, but it rotates when the load is not present, but still our disc will rotate. If the load is absent, then also this our disc will rotate, and this disc rotates slowly, but it continues to rotate, and this error is called as creeping error. Okay, it is called as creeping error. So to minimize it, what we have to do, if this is our disc, okay, this is our disc, and here there are two magnets, shunt and series. So what we have to do, we have to drill some small holes over this. So then what will happen, it will not cut flux, right? It will not cut flux. So this is one error. Second error is due to the temperature. If the surrounding temperature changes, then error may happen in our energy meter. So this is about the energy meter. Just remember, it has three magnets: shunt magnet, series magnet. To shunt magnet, it is E-shaped, series magnet, it is C-shaped, and braking magnet, it is placed here between the aluminium disc. Now here what happens, I have given the supply, this is the coil, neutral, it is getting neutral. Same to this series, we have connected it to load and then given to the neutral. Now here this is aluminium disc. When current starts flowing, what will happen, magnetic flux will be created. This flux will cut this aluminium disc, and due to that what will happen, this will rotate, and due to that rotation we will get here units. Now we have to control this rotation, so we have connected here braking magnet. Now here sometimes they connect copper, what we can say, a copper ring that we connect here. Why? To create the phase difference. If there is phase difference, then and then flux will create, and our disc will start to rotate. To rotate our disc, we need a phase difference, right? So to create that phase difference, sometimes what happens, the phase difference is not created, so our disc will not rotate. To create that disc, to create that phase difference, we connect here copper ring, so that what happens, the phase difference is created and our aluminium disc starts rotating. So this is about the energy meter.